So, as I've been introduced, my name is Sakthy Selvakumaran, and I'm going to talk about data from space. And it's very easy to get swept up in this kind of, especially as civil engineers, this cool idea of space and data and all these exciting things, and it sounds a bit flashy. But in this context, I more wanted to talk about, well, what actual value as civil engineers can we get? So my own background is as a practicing civil engineer. I worked in industry for many years, in consultancy and on behalf of construction companies. And then I retrained working at the German Aerospace Center, the kind of space agency in Munich, on how to process satellite data, but specifically looking at it from the point of view as civil engineers, what can we do to actually add value to our own? At that time, I was just thinking about general structural health monitoring, but now into this idea of digital twins. And so this is a slide that you should all be kind of familiar with if you engage in this kind of community, but really thinking about what we're using with our data. Why do we want to collect it? And what do we want it for? Not just in the initial kind of design and construction, but how can we use that to make interventions in better planning, operations, and maintenance? And for me, my own personal drive in this is around managing increasing risks. So obviously with the events of things like climate change, we're seeing increasing number of failures, increasing the unusual loads on our aging and deteriorating infrastructure assets. And satellite data to me provides this opportunity to take a kind of new data set over wide geographical areas and help support some of those critical decisions being made. And so there's this point at the beginning where you start on this journey and you think, okay, satellite data, what's there? And as you can see on this slide, there's loads of stuff out there. There's digital models, there's the obvious optical data, which you can use for change detections. There's hyperspectral data, which you can use for various types of land and vegetation classification. You can measure all kinds of things like air particulates. You can measure damage detection, fire mapping, all of this kind of stuff. And I have no time to tell you about them all here. So what I thought I'd do is focus on one particular aspect, which is gaining interest in our own sector, and kind of point you towards some of the considerations around this, particularly because it is the focus of a CDBB project, a research project between the University of Leeds and the University of Cambridge. And what this is something called INSAR, which I'll tell you a bit about how it works in a second. But effectively, all of the points mapped in this image are points that are collected by radar measurement. And so each of these points represents a velocity of a point on the ground moving over time. And what we can see here is an area of central London which looks like it is sinking. Now, in this case, there's a reason for that. This is where the tunnelling works were going on for London Underground at Bank Station. So this is tunnel settlement, which we would expect to see. And I'll tell you a little bit more about how London Underground is using this data, or is thinking about using this data in the future. But essentially, what you can see here is that it provides wide area. So this is just a small section of data. One satellite image is, the size of London itself, or the size of East Anglia, depending on the satellite resolution. And what we can use it for is monitoring small-scale deformations over time. So in this case, we're measuring just a few millimeters or tens of millimeters of ground settlement. So what is INSAR? It's called Interferometric Synthetic Aperture Radar, and effectively it works by a satellite passing over the Earth and emitting radar. This radar then bounces off various different objects. So on the image on the top right, you can see a raw radar image. So things like mountains and cities reflect well, the bright spots. And then the next time the satellite passes around again, it takes another image. And what we can do is think of each of these waves as a kind of sine wave going from the satellite down to Earth and back. And what we do is we measure the difference between reflections. So if the object on the ground has moved, we can measure that. And so this is how we end up with a time series of measurements over time. And what's really interesting about this is that we can use that to study structures going forward, but we can also use it to go backwards. So if, say, in this example, we have just a bridge that we know nothing about, we're a bit concerned about it, or we want to find out more, we can use the historic archive of satellite data available to look backwards in time, and then give us some idea of what the structure was doing. So in this case, we can see that actually it's moving pretty much in line with thermal expansion. Some of the work that our engineers are doing on this project relate to helping us on the ground make better use of this asset. So I kind of hinted that in this type of data, certain objects reflect very well. Sometimes things don't reflect very well. And what we can do is install additional pieces of kit on the ground to help us get better reflections. So in the equivalent idea of sticking a survey prism and using an automated total station, we can stick corner reflectors on the ground and get specific points monitored over time. What Christina has been doing is looking at whether we can take these quite large reflectors and put much smaller versions on existing assets, which is kind of interesting, not just in terms of retrofit, but in terms of thinking about how the future assets are designed so that we could maybe incorporate this within architectural or structural features to do this without having to mount a reflector on top of it. We've done this actually in a previous study on Waterloo Bridge. So if you look over the side of Waterloo Bridge very carefully, you can see a couple of these mounted. And similarly, these basically amplify that radar response. So we're able to monitor specific points in millimeter resolution over time. But the key thing about this type of data is to understand when it is and isn't useful. So satellite data is collected every few days rather than every few minutes or hours. And in the case of bank tunneling, we did an academic trial where a number of different sensors solutions were trialed by the Center for Smart Infrastructure and Construction, including fiber optics, classical studs and prisms that you'd use for surveying, and putting all of that together. Some things are quite useful, for example, in the example of tunneling, to know right there and then when the tunneling is happening, and you want to know that every hour or every minute of the day. Other things like satellites might be more useful when you're looking at wide area deformation. So how big is the effect of tunnel settlement? And if you have to monitor this for years after the tunneling is complete, this could provide a more cost-effective solution in being able to kind of automatically collect data every 6 days rather than sending someone out to site every 6 days. Gabriel in our group is working on one step further from this. So once you get these kinds of measurements, how do we deal with the sheer volume of data? And actually, there are various, excuse the buzzword of machine learning, but various types of data analysis techniques which we can take to deal with the large volumes of data generated by satellites. So in this case, if you imagine like all of these points contain a time series, and you're looking at a time series over a very large area like the entire city of London, perhaps it's quite difficult to figure out what's going on point by point, but instead we can employ strategies to collect certain key behaviors, and in this case, look for time behaviors of interest, so oscillations or step changes or settlement and things like that. Zara, on the other hand, has been looking at INSAR data from the point of view of combining it with existing assets, existing models and digital twin information. So there's one thing where you go to a satellite company and you say, okay, I'd like some satellite data processed. But what becomes more interesting is if you as an informed user can go and say, look, I have this kind of information, I know this structurally, I have these kinds of models, and engage in a dialogue between them to better improve the output of that data. So what Zara was doing was modeling radar reflections, which can actually help with the interpretation of the output of the satellite data. INSAR data doesn't view the same way as optical data, so there are some location and interpretation challenges, which if we as civil engineers meet satellite processing people somewhere in the middle, the sum of those two parts are actually more valuable than either of our individual contributions. And so overall, as I've run out of time, the key point of what I wanted to say here is that what I've done is basically thrown a lot of information at you and dropped a lot of breadcrumbs. It's by no means a detailed analysis or explanation as to how you can leverage satellite data, but what I was hoping to do was kind of just get the thought process to show people that, hey, there is a lot of data out there. And actually the key things that you want to understand is that there are many different types of sensors that measure many different types of things. So similarly to the question of traditional sensors, you have to ask yourself, what do you want to achieve overall? Why do you want to monitor it? What do you need to know? Is it movement? Is it classification? Is it change detection? All of these things are important conversations. Processing this data itself is sometimes easy, sometimes like INSAR, it is very technical and challenging. And really what you want to do is deploy an expert rather than try and train yourself how to do it. So it's all about having a conversation with the right types of suppliers. There are many different satellite companies, as well as consultants, as well as academics out there who can help signpost you through that journey. And finally, the best interaction is a two-way conversation. So as I said, there's something to be said about working with satellite experts, but they don't know very much about structural behaviors or how the built environment works. And so the most valuable output is the sum of those two contributions together. Thank you.
So the next couple of questions are for Sakthy and your presentation here. So the first one is, would you share some more possible use cases?
Yeah, there's many of those. Everything from monitoring ground heave to, as we said, dams to for INSAR, this is any kind of structural asset. The main thing is that you have to understand what it can and cannot do. So like a couple of things I didn't mention are like satellites are sideways looking. And so they measure in line of sight of the satellite. And so you have to understand how that translation is made into what civil engineers traditionally want to know in, say, like X, Y, Z directions. But it really does depend on what the asset is and how much it moves. It can't do anything below the ground surface, but it can measure tunnel settlement and things like that. So yeah, many more cases.
The next linked question to that is a centralized open data source or database being planned to release these types of different satellite data / imagery?
Yes, that's a good point. I didn't mention it. There are many different data sources. Some are commercial and some are open access. So there's a number of different high resolution, very frequent, very small pixel sizes of like half a meter by half a meter pixels and all this kind of stuff. The images that I was showing you were a mixture of free and commercial grade data. So the most interesting thing to go and have a look at is the European Space Agency has something called the Copernicus program. So if you Google Copernicus open access, you'll find basically lots of freely available satellite images collected every 6 days in terms of radar format, optical format, pollution data, all this kind of stuff. But the European Space Agency makes a lot of that kind of stuff openly available. And if you need something in a higher, but it also just collects data regularly because it's not commercially driven. They don't task a satellite. It's always collecting, especially over Europe every 6 days. Commercial satellites tend to task for specific sources. So the archive of data is a bit patchy, but the combination of the two is kind of quite useful because you have that regular data from Europe and it's free. And then you can combine that with commercial grade data if you need something specific. The main cost of it here is that for, say, something like INSAR, you'll want a specialist to process it and you'll have to pay for their time to process that.
Brilliant. And one here about planning permission restrictions.
Yeah, this is one where you do have to plan. So for example, you need an asset owner who, I was looking at a study with Transport for London on Hammersmith flyover, which I ended up just monitoring without reflectors. But if you install, they had an issue where if you, obviously they don't want it above, like visible to cars because that's a kind of distraction, but then they don't want it mounted on the side of the parapet because that voided the warranty. And so there's a bit of a challenge there. Waterloo Bridge, they were already kind of doing maintenance work and putting in traditional prisms, so they installed them next to them, and that was fine. But it is a consideration that you need to plan. And even if you're, say, installing it in the middle of a field, you need to consider like you might need to cast a base, like a concrete slab or something, to sit it on top of. Things like that are all practical. But it's the same as sensors. You just need to think about the practicalities of it a little bit.
Brilliant. And the final question, then we'll come to an end, is do you see any opportunities to use satellite imagery to monitor interactions between the built environment and the natural environment?
Yeah, so that's kind of a lot of the work that both I do as in research and also my company BKwai does is not just the simple processing of satellite data, but putting that all together in both the built and the natural environment context. And so I work in what I call multimodal or data fusion of putting the different sources together. So I don't tend to use just INSAR or just optical, but actually getting the benefits of each of these different types of sensors together with some ground information and saying, okay, well, what is the environmental effect on this built environment asset? And then actually you can kind of get into really quite interesting things where you then take in you can scrape in quite a lot of environmental data, understand the correlations, and then forecast forward and then do kind of, so on the commercial side with my company, we've done some studies we've done a piece of work with Thames Tideway. Where we were looking at a site where they were working underground, which was impacted by various weather effects, and then use that to kind of forecast forward to predict when it would be safe to put people and equipment into the ground where they were working.